Alright, I was going to work some more of the problems that you might have in your pre-cal section on quadratic equations. I'm going to do number 18 because it's got a negative out front. When you see this problem, you might be thinking f of x. You might be thinking that you could factor this if you just factored the negative out. Maybe you could get it to factor, but it won't. You can try it, but it won't. So what we're going to do, we're supposed to be graphing this, and they want to know what the vertex is, and they want to know the x-intercept. So I've got the graph here, and we'll put our x-intercepts down here. And remember, with x-intercepts, the y value is going to be 0. The opposite variable is always 0. So that's part of what we need to answer. We'll also talk about whether it's a maximum or a minimum and all that kind of stuff as we're going. Now, since this won't factor, if I want to find the vertex, there's a couple of choices I have. Actually, I wouldn't need to factor it to find the vertex anyway, but if I wanted to find the vertex, what I could do is either use that little formula, x equal negative b over 2a, or we could complete the square and find it that way. And since the other way is faster, we're just going to go ahead and find the vertex using this little x equal negative b over 2a formula. That's going to find the x-coordinate of the vertex down here. And then to find the y-coordinate, I'll have to plug this x into the formula. So I'm probably going to want my calculator handy so that I can type this in and have a table available. And actually, that's what I'm doing right now, so I'm kind of pausing here. Okay, so my a here, let me label some things. My a here is my coefficient of my x squared term, it's -1. My b here is the coefficient of my x term, it's -4. And my c here is 1. So if I do this formula, negative b is -4, over 2 times a is -1, equal +4, it's hard to read that, but hopefully you're thinking and not just copying, right? It'd be a +4 over a -2. And +4 divided by -2 is -2. So that's the x-coordinate of our vertex. Now I've already typed on my calculator this equation, and I find out that the y is 5. I could have plugged it in by hand, but I'm going to take shortcuts where I can. All right, so there's my vertex. I can go graph that. -2, 5. It's going to be right here. Now I know this is going to open downward, don't I? Because it has a negative a term. If the coefficient of the x squared is negative, it's going to open down. So I know that's going to happen. Okay, so now I've got my vertex. The other things that are important on this graph usually are the x-intercepts. They're the solutions to the equation anyway. So in order to find the x-intercepts, I can either factor, and this one won't factor, so I can use the quadratic formula, x equal negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so now I need those same a's and b's from above. I'm going to do this, and it's always a good idea. Kept me from making many a mistake once I got in the habit of doing this. Go ahead and put all the blanks as parentheses where you're going to fill in something. Okay, a is -1. So everywhere I need an a, I'm going to stick a -1. There's a -1 there. B is -4. That's out front. It's a negative sign and a 4. Here's a -4. And then the C is 1, and there's just one of the C's. So when we go to reduce this, we get x equal 4 plus or minus the square root of c. -4 squared is 16, and then -4 times a -1 times a 1 is a +4, so it's 16 plus 4 over -2. And that 16 plus 4 ends up being -20, it ends up being 20, so let me just stick it under there. I'm going to go to another page for this because I'm running out of room. Okay, so now we need to reduce this. There's all kinds of things from Algebra 2 we're supposed to remember, and if you don't remember them, you really have to kind of do some fast catching up here. First of all, I'm pretty sure that this is going to reduce because I see a 2 and a 4, and I know that I can reduce the square root of 20. Square root of 20 can be rewritten as, if I'm thinking of a perfect square, 4 is a perfect square, 4 times 5 is 20, all over negative 2. All right, so now I get x equal 4 plus or minus. Now remember, when you're taking the square root of two things multiplied, you can just square root them independently. The square root of 4 is 2, and square root of 5 is left inside the bracket, all over negative 2. Okay, so now I want to cancel out that negative 2. Here's one way to do it if you get confused. Let's factor a negative 2 out of the top because there's one on the bottom, okay? 4 divided by negative 2 is negative 2. Now plus or minus, if I divide by negative, it just switches the signs of each one of them, so I still end up with 1 plus and 1 minus. It really doesn't affect it there. And if I take out the 2, then I've got a square root of 5 left. So the square root of 2's are going to cancel out then, and it's going to be negative 2 plus or minus the square root of 5. Now, if I'm going to graph this, it's kind of hard to know what that value really is. So let me go in the calculator and go to my home screen, which is just, where you just do your regular calculations, not on the y equal button. Negative 2 plus the square root of 5 is equal to about, that's x is about 0.2, I'm just going to go to 2 decimal places, about 0.24. And then negative 2 minus the square root of 5 is actually negative 4.24. Okay, so let's graph these. Let me get some more little lines here on my graph. All right, 0.24, that's going to be close in here. It's probably going to be hard to discern because the dot's so big for my stylus. Negative 4.24, negative 1, 2, negative 3, negative 4. It's going to be somewhere between negative 4 and 5. So roughly, if I draw my parabola, it's going to look like this. My A was negative, so my parabola opens down. That makes the vertex here a maximum because it's the highest point on the graph. If I were to talk about the domain and the range of this, just to continue that discussion, since that was an area a lot of people had trouble with, my Y's are all less than or equal to 5. That would be my range. And I can pick any x I want to and plug it into the equation. So for my domain, x's are always any real number I want to pick because I can plug any x in I want to. That's one way to look at it. And then your range was, again, that y has got to be less than or equal to 5.